I'm Quốc Huang from Taiwan. I'm happy to have this opportunity to give a talk regarding the approach to conducting STEM research in the mobile era. In recent years, the concept of education has changed from teacher-centered to learner-centered. This implies that the role of teacher has changed as well. Nowadays, teachers play the role of not only a knowledge deliverer, but also a learning facilitator. That is, they need to design activity to engage students in teamwork to identify and solve problems or complete some projects. They also need to guide students to apply knowledge and skill learned from multiple disciplines. This is why STEM education has attracted the attention of school teachers and educational researchers in the world. The aim of STEM education is to cultivate students' ability to effectively use science, technology, engineering, and mathematics knowledge to solve problems. It also aims to enhance students' critical thinking and creative thinking by interacting with peers and thinking diversely. There are two types of STEM activity design. The first one is project-based learning, in which students are asked to complete a project, maybe on their own or in a team. Students need to use the knowledge and skill learned from science, technology, engineering, and mathematics courses to complete the project. For example, they might be asked to design, implement, and control a car or a robot. The second type of STEM task is inquiry-based learning, in which students use multidisciplinary knowledge and skill to investigate, identify problems, and propose possible solutions. During the inquiry-based learning process, they need to make observations, collect data, and analyze the data for solving problems. To know more about the research status of STEM education, we have reviewed the publication of SHI journal in the field of educational technology, educational science, and engineering education, science education, and mathematics education. This slide shows the number of STEM-related publications in each year. As we can see from the slide, the number has increased rapidly, in particular in recent 10 years. That is, from 2010 to 2020. We also found that the number of publications in science, engineering, and mathematics education is more than that in educational science and educational technology journals. There are a total of 744 articles published in those journals, and among the articles, 520 articles were published in science, engineering, and mathematics journal. Only 224 articles were published in educational science or educational technology journals. We also found that for educational technology researchers or school teachers, designing STEM activity remains a challenge to them. So it is important to help teachers and researchers to develop STEM activity with effective strategy or tools. We also found that a majority of STEM educational research mainly examine teachers or students' perception of STEM learning or teaching. For example, some authors explore the influence of school environment and individual factors on teachers' attitude toward STEM education. On the other hand, only few studies have been conducted to use effective learning strategy in STEM activity. This implies that the design of true or course experiment to investigate the effect of adapting learning strategy in STEM activity on students' performance from different perspectives is necessary. To sum up, there are several challenges for school teachers or researchers to develop STEM activity. For example, teachers usually design activity for a single curriculum, so they might find it difficult to consider learning activity from an interdisciplinary perspective. It is also challenging to incorporate effective learning strategy into the activity to meet the goal of STEM education. So here is my suggestion. The teacher or researchers can try to develop STEM activity in a progressive manner. That is, they can start the design from a subject and then consider how the knowledge of other subjects can be added or can be applied in the activity. I would also like to discuss the role of mobile technology in STEM education. I think mobile and wireless communication technology can offer new perspective and opportunity for STEM activity design. For example, it can allow learners to observe and collect data in the real-world environment. It also facilitates information sharing and collaboration among peers. It also enables students to learn across contexts. So in STEM learning activity, mobile and wireless communication technology can facilitate learning across the real world and the virtual worlds. In my opinion, the use of mobile technology particularly benefits the inquiry-based STEM activity, enable students to collect data in the field, to make observations in the field. Also, students can seek help, discuss with peers, share what they have found, or access the learning materials in anywhere and at any time. As I have mentioned earlier, there are two types of STEM activity. That is project-based learning and inquiry-based learning. Both types of activity aim to engage students in higher order thinking when they try to complete the learning task, such as applying knowledge to solve problems, analyzing the correct data, evaluating the proposed solution, or proposing new ideas. Also, it should be noted that collaboration is generally required for the student to complete a complex task. This implies that collaboration and communication could also be important goal of STEM. From the perspective of research design, when we try to conduct some STEM education research, we might consider, evaluate, or measure students' communication, collaboration, critical thinking, problem solving, computational thinking, metacognition, or creative thinking performance or tendency. From the perspective of Bloom's educational objective, the aim of STEM education mainly focuses on those higher order thinking performance or higher connection level, such as apply, analyze, evaluate, and create. It is important for researchers to consider those high-order thinking competence as well as those items I just mentioned, such as communication and collaboration performance in STEM activity. I would also like to recommend some measuring tools for STEM researchers. Here are some questionnaires developed by a previous study. For example, the problem-solving tendency questionnaire proposed by the author in 2014 and metacognition tendency proposed in 1994. The critical thinking awareness questionnaire proposed in 2015. The collaboration tendency questionnaire proposed in 2014. The communication tendency questionnaire proposed in 2013. And the creative thinking tendency proposed in 2016. I also like to recommend another measuring tool for computational thinking tendency. This measure is proposed by me and my colleague Professor Lai in 2020 in the International Journal of Mobile Learning Organization. This is an example of project-based STEM activity. In this activity, the students are asked to design a Ruby Goldberg machine, which is a chain reaction type of machine. In these activities, the students need to use the knowledge of science, technology, engineering, and mathematics to construct a series of simple devices. And the students need to design trigger mechanism between the devices, such as a ball hitting a piece of wood to start the next move. After the chain reaction, the device needs to be able to achieve the final goal. This slide shows an example of an inquiry-based STEM activity. In this activity, the students are asked to explore the acidification problems in the ocean. They need to record the pH value of the ocean in a specified area in each time period. And after several weeks or several months, they can collect a series of data and then use linear regression analysis to predict the pH value in the coming years. So, based on the data they collect and the analysis result, they can predict possible harmful consequences to marine life and the future food chain connected to the ocean. There are several advantages of using mobile technology in STEM activity. I should call that mobile-based STEM. For example, students can use mobile device to collect data or to access supplementary material in the field. They can also learn across contexts with the help of mobile and wireless communication. This implies that they can apply what they have learned in school to the real-life problems. So, the use of mobile technology can increase the connection between formal course content and the students' daily life experiences. They can do that via some discussion forum to share experience and the data collect from the living environment. As I have mentioned earlier, designing a STEM activity is usually a challenge to school teachers and the researchers. So here I would like to demonstrate some approach to conduct a STEM activity from a single course. In this example, the task is to develop a smart greenhouse. This is an engineering problem. We start from an engineering courses, then this implies that we need to add the knowledge from other courses. For example, when trying to develop greenhouses, the student need to use computer concept to control the lighting and the air condition. Also, they need to use scientific concept to select the right building material for develop the smart greenhouses. They also need to use mathematical concept to collect data, calculate, and design the best building for the environment. So this is a typical STEM activity designed from an engineering course. This is another activity designed from a science courses. The aim of this activity is to build an automatic garbage sorter. This is a science issue. So we already have science concept, and then we need to add the knowledge of other courses. Regarding the engineering concept, the student need to develop a mechanical arm for sorting the garbage. Also, they need to use computer concept to design a program to control the mechanical arm, and they also use mathematical concept to define the formula for robot walking and throwing the garbage. This slide shows a STEM activity designed from a computer course. In this task, the student need to use open source hardware, that is a computer technology, to build a car and a wireless steering wheel to control the car. The student need to use engineering concept to design the mechanical part of the car. They also need to use a scientific concept to determine the motor power and the direction of the car. Also, they need to use mathematical concept to calculate the engine power as well as the distance and the speed of the car. Now I would like to introduce some strategy for conducting mobile-based STEM activity, including theme-based discussion, knowledge building tools, inquiry-based learning, peer competition or gamification, personal project-based learning, collaborative project-based learning, and peer assessment. With the help of those strategies, the students' learning performance in STEM activity could be promoted. Also, when choosing proper strategy to work with mobile-based STEM, we can add innovation to our research. Theme-based discussion is the strategy that engages students in discussing the issues raised by the teacher. This strategy can be adapted to work with inquiry-based STEM activity. That is, after students complete their inquiry in the field, they can have a discussion to share their experience or findings. From the perspective of research design, researchers can investigate the relationship between student discussion quality and STEM performances. Knowledge building tools are the tools that help students construct and organize knowledge, such as the well-known concept map or mind map. This tool can work with both project-based STEM activity for brainstorming or project design, and inquiry-based STEM activity for organizing concepts and identifying problems. Peer assessment is the strategy that engages students in critical and reflective thinking while assessing peers' work and receiving rating or comments from peers based on the rubrics provided by the teacher. This strategy is usually used after the student complete a STEM project or presenting their inquiry reports. Peer competition or gamification is the strategy that engages students in a competition during the STEM activity. For example, the teacher can design a STEM game called an escape room. In this activity, students apply science, mathematics, and engineering knowledge to solve problems. Then they can also use mobile devices to discuss or search for clues. And the first group that completed the task is the winner. In the following, I would like to present a video to show how a project-based STEM program is implemented in a high school in Taiwan.
The Adventure of a Tech Ball is a STEM program of Neihu High School, located in northern Taiwan. In this program, the students are guided to use the concept of technology, physics, mathematics, and engineering to create a three-dimensional math with building blocks. They need to design the structures and create clever labels of the 3D math, as well as writing computer programs to control the tech ball. That is, they are engaged in computational thinking to face the challenges in every level to complete the task. This is a concrete practice that allows students to show their ability of applying interdisciplinary knowledge, including scientific, mathematical, technological, and engineering concepts, as well as creative thinking to solve problems. In the process of this project-based STEM activity, teachers and students use mobile devices and the G Suite learning platform to record and share their learning experiences. Moreover, several mobile learning strategies such as video sharing, thematic discussion, peer assessment, and group competition have been adopted to enhance the students' STEM learning performance. It is concluded that the project-based STEM program with effective mobile learning strategies has successfully employed the 4 P elements of creative thinking, that is, projects, patient, peers, and play, with which the students develop the competence of creativity, frustration tolerance, and problem solving.
There are several potential research topics for mobile-based STEM study. From the perspective of the role of technology, the researcher can consider how can mobile technology support students in completing STEM tasks. For example, to enable data collection and to facilitate collaborative work. Researchers can also consider how emerging technology such as VR, AR, or AI can be used to improve students' STEM learning performances. From the perspective of learning design or research focusing, researchers can consider what new strategy can be used to improve students' higher order thinking, as well as their learning performances in STEM activity. They can also compare the impacts of using different learning strategies in STEM activity on students' learning performances. Also, they can investigate what are the differences between the interactive behavior of the student using different strategies in STEM activity. From the perspective of learning system design, researchers can consider what kind of learning system or apps can be used to support STEM activity. Also, they can consider what new features of the learning system or apps are needed to better support STEM activity. Finally, from the perspective of policy or human factor, researchers can consider what are the factors such as technology acceptance, self-efficacy, technology background affecting teachers or student engagement or attitude in STEM education. They can also investigate how to promote teachers' belief in STEM education. Also, how to effectively train or assist teachers to design STEM activity. There are several possible STEM research design approaches. For example, in this slide I show a design to investigate the impact of using new technology such as AI application on student learning performance and perception in STEM activity. In the Explorer group, I call it AI supported STEM. So the AI could be AI-based chatbot or some image recognition application or some AI-supported formatting assessment or AI-supported inquiry-based learning. The control group use a conventional STEM. They should be a pre-test or pre-questionnaire and post-questionnaire. So in addition to learning achievement, researchers can also measure learning motivation, self-efficacy, learning anxiety, or high-order thinking performance of the student. This is another research design approach. In this approach, we try to investigate the impacts of incorporating different strategies, such as collaboration or peer assessment, on students' learning performances and perception in STEM activity. For the Explorer group, the strategy could be, for example, collaborative STEM project, or a concept mapping based STEM project, or gamified STEM project, or peer assessment based STEM. And for the control group, they learn with the conventional STEM. Similarly, in addition to measure student learning achievement, we can also measure their learning motivation, self-efficacy, learning anxiety, or other higher order thinking performances in the pre-test and post-test. So I would like to make a conclusion. In this talk, I try to deliver several messages. First, we can design STEM activity from the perspective of project-based learning or inquiry-based learning. And we can investigate the impacts of using different technology in a STEM activity on student learning performances and perception. We can also investigate the impacts of using different strategies in STEM activity on students' learning performance and perception. This is the end of my talk. Thank you for your attention.